computers make you curious? Did you ever had the curiosity that how are computers built? How do they work? Or do you have the willingness to gain the wonderful knowledge that comes along with the process of building a computer entirely from scratch? Then yes, this course is for you. So the basic prerequisites for this course is that you must have a basic knowledge of current electricity till class 10th, basic arithmetics, basic calculations of exponents and powers, and you must have a willingness to learn and mess with the circuits. And then you must have curiosity and passion for computers. We have tried our level best to make this course beginner friendly, so let us begin. Building a computer from scratch can be a really very Herculean task, but once you gain the basic fundamentals behind all its process, then it's a very simple task. It can be a cakewalk as well. So we have divided this series into small parts so that one can get a thorough understanding of all its process. So in the very first part we are going to discuss about the analog components because it is extremely useful to grasp the basic of the analog components because they are the basic building blocks of the computer. If we draw a current voltage graph for two wires, then we get different slopes. So what makes the slopes different? It is the resistance which makes the slopes vary. So current, voltage and resistance go hand in hand in a circuit. The relation between the three can be expressed with Ohm's law, which is V is equal to IR. In other words, voltage equals the current in amperes multiplied by resistance in ohms. Ohm's law is one of the most important formula in electronics. It is used at many places. Very important application of resistance in the building of computer is the voltage divider. So how will you determine the resistance value of a resistor with the help of color codes? For this, a clear chart is given here. Everything clearly mentioned how you can calculate the resistance. So you can even use an online tool for, and the link for it will be provided in the description box. Let us move on to capacitors. They play a very important role in the clocks of the computer. So basically they are a device which stores the energy. But batteries and capacitors both stores energy. Batteries and capacitors both can generate potential difference. So how are they different? They are different. Let us see how. Capacitors and batteries are different, the way they release energy. So to understand it, we can take an example of a dam. So dam has small doors in it through which water flows constantly till it does not get finished. Or we can also say make think water as an energy, so the energy is released till it is not finished. So this is how the battery works. So what if I break this dam completely? The water will be released in at a very high speed in just a small period of time. So this is how capacitors work. In just a small period of time, a lot of energy is released. So this is where the applications of capacitors come. Batteries and capacitors are different in the way they store the energy. A battery generally stores energy in the form of electrochemical cells with external connections for powering the electrical devices, whereas the capacitors needs to be charged before they release the energy. Camera flash is really good application of capacitors. The moment you click a photo, you get to see a flash. there's a capacitor working behind this in the camera. So the moment a flash is clicked, capacitors release a very high amount of energy to let the flash happen. And the moment it gets over, the energy gets over, it gets discharged. It needs to be charged again. The camera needs to be charged again. So this is a very important equation which we will require ahead when we will be working with the clock of our computer. This is a very important formula where tau is the time constant in seconds. It is equal to RC, where R is the resistance and C is the capacitance. Remember this formula, we will require it ahead. If we are building a computer, then diodes comes in handy. So let us start with its fundamentals. Semiconductors can be classified into two, extrinsic and intrinsic. And extrinsic can be further classified into p-type and n-type. P-type contains the trivalent impurities and n-type contains the pentavalent impurities. So majority charge carriers in the p-type are the holes and the minority charge carriers are the electrons. And in n-type, the majority charge carriers are the electrons and the minority charge carriers are the holes. So what if we combine this p-type and n-type, then what will happen? Then there will be a disbalance of the concentration. So the electrons which are very much near to the junction, they start moving to the other side where there is a vacancy. So this process lead to the formation of the depletion layer. If you attach the P side with the positive, then you get the forward bias, and if you attach the negative, then you get the reverse bias. In forward bias, current is due to the majority charge carriers, and in reverse bias, very small current due to the minority charge carriers. Computer consists of thousands of logic gates made of transistors. Transistors operates like a valve and that is operated by current. A BJT has three pins, the collector, the emitter and the base. So transistors can be classified into two, the NPN and the PNP. So the emitter can be classified as the moderate size and its doping is highly doped. Base is very thin and lightly doped. Collector is too large and moderately doped. So now let us understand the working of transistor. So the emitter side N is connected to negative terminal. So it will be termed as forward bias. And the collector side N type is connected to positive. So it is the reverse bias. The so because of this, the electron will start flowing from left to right and the flow of current will be exactly opposite to it. So IE will be flow as shown in the figure. So here IB is the base current and it is very small. So IE is the total of IC plus IB. IC is the collector current and IB is the base current. So these are the some very important formula which we will require when we will be constructing our computer, and there we will discuss it in more detail.